Hello and welcome to Astronomy Daily. I'm Anna, your cosmic companion as we explore the wonders of the universe together. Today's episode is packed with discoveries that remind us just how vast and mysterious our cosmos really is. From oxygen found in the most distant galaxy ever observed to evidence suggesting supernovae may have triggered mass extinctions right here on Earth, we're covering the full spectrum of astronomical fascination. And that's just the beginning. We'll also explore revolutionary new telescope technology that could transform how we see the stars, examine an extraordinary nova explosion that outshines our sun 100 times over, and discuss Venus's current celestial positioning as it passes between Earth and our star. Plus, we'll delve into the theoretical realm with a fascinating new study on Dyson swarms, those hypothetical megastructures that advanced civilizations might build around their stars, and the startling impact they could have on planetary environments. The universe continues to surprise us at every turn, challenging our understanding and expanding our cosmic perspective. Whether you're a seasoned stargazer or just curious about what lies beyond our atmosphere, I promise you'll find something to marvel at in today's roundup of astronomical news. So get comfortable as we embark on this 25-minute journey through the cosmos, exploring the latest breakthroughs, discoveries, and theoretical frontiers that are shaping our understanding of space. From the earliest moments of our universe to the potential future of advanced civilizations, we're covering it all on today's episode of Astronomy Daily. In a discovery that's pushing the boundaries of what we thought we knew about the early universe, astronomers have detected oxygen in the most distant galaxy ever observed. This isn't just any finding. It's the farthest detection of oxygen ever made by humanity, giving us a glimpse into cosmic conditions when the universe was just a cosmic toddler. The galaxy in question, designated with the rather unwieldy name Jades GSZ14.0, was spotted by the James Webb Space Telescope earlier this year. What makes this discovery so remarkable is that the light from this galaxy has taken about 13.4 billion years to reach us. That's a journey spanning 98% of our universe's 13.8 billion-year lifetime. But here's where things get really interesting. This ancient galaxy contains about 10 times the amount of heavy elements that scientists would expect to find in a galaxy existing just 300 million years after the Big Bang. As researcher Sander Schoes from Leiden Observatory put it, it is like finding an adolescent where you would only expect babies. To understand why astronomers are so excited, we need to consider what the infant universe was supposed to look like. In those early cosmic days, the universe was primarily filled with hydrogen and helium, the lightest elements. Heavier elements, which astronomers somewhat confusingly call metals, were extremely rare. These heavier elements are forged inside stars and scattered through space when those stars die in supernova explosions. This process then enriches gas clouds that form the next generation of stars. It's essentially a cosmic recycling program that becomes more efficient over time. So finding a galaxy so metal-rich this early in cosmic history suggests that Jades GSZ14.0 matured much faster than our models predicted. This discovery is forcing astronomers to reconsider their understanding of how quickly galaxies can form and evolve in the early universe. The chemical analysis of this distant galaxy was made possible through a collaboration between the James Webb Space Telescope and the Atacama Large Millimeter Submillimeter Array, or ALMA for short. While Webb discovered the galaxy, ALMA's measurements allowed astronomers to determine its chemical composition with astonishing precision. Stefano Carniani of the Scuola Normale Superiore in Italy expressed his astonishment at these unexpected results, noting that they opened a new view on the first phases of galaxy evolution. The evidence that a galaxy is already mature in what we considered the infant universe raises profound questions about when and how galaxies formed. Perhaps even more impressive is the precision of ALMA's measurements. According to researcher Eleonora Parlanti, ALMA provided an extraordinarily precise measurement of the galaxy's distance down to an uncertainty of just 0.005%. To put that in perspective, that's like measuring a distance of 1 kilometer with an accuracy of just 5 centimeters. This discovery highlights the incredible synergy between our newest space telescope, James Webb, and ground-based observatories like ALMA. Together, they're giving us an unprecedented look at the earliest chapters of our universe's story, revealing that cosmic evolution may have proceeded much faster than we previously thought. As astronomer Richard Bowens noted, this finding showcases the amazing synergy between ALMA and JWST to reveal the formation and evolution of the first galaxies. It seems that with each new observation, we're rewriting the timeline of cosmic history. Next up today, did you know that the dinosaurs might have been wiped out by cosmic fireworks? While an asteroid impact has long been the leading theory for their extinction, new research suggests that explosive supernova deaths of nearby massive stars may have played a significant role in triggering at least two major extinction events in Earth's distant past. A team of astronomers has discovered that supernovae occurring within 60 light-years of Earth could have had catastrophic consequences for life on our planet. These stellar explosions represent some of the most energetic phenomena in the universe, and their proximity to Earth could have stripped our planet's atmosphere of its protective ozone layer. Without this crucial defense, life on Earth would have been exposed to damaging ultraviolet radiation from the sun. As study co-author Nick Wright from Keele University put it, a slightly more distant supernova could still cause considerable loss of life, but at this distance, it would be terrifying. Wright and his colleagues conducted what amounts to a virtual census of our cosmic neighborhood. Using data from the now-retired Gaia satellite, they examined more than 24,000 of the most luminous stars within about 3,260 light-years of the sun. Their goal was to identify groups of young, massive stars and reconstruct the history of star formation near our solar system. What's particularly striking is that when the team calculated the rate of nearby supernovae, they found it matched up remarkably well with the timing of unexplained mass extinction events on Earth. Two events in particular stood out: the late Devonian extinction about 372 million years ago, which wiped out 75% of all species, particularly affecting fish in ancient seas and lakes, and the Ordovician extinction from 445 million years ago, which eliminated roughly 85% of marine species. It surprised me that the two rates were so similar, which made us want to highlight it, Wright noted. Previous research has already found evidence supporting cosmic influence on Earth's history. Scientists have detected radioactive isotopes like iron-60 in Antarctic snow and on the moon's surface, materials that could only have come from interstellar sources like supernovae. These findings have been linked to the depletion of Earth's ozone layer caused by cosmic rays showered onto our planet when stars exploded. The new study's simulations showed that approximately 1 to 2 supernovae occur each century in galaxies like our Milky Way. More critically, within that dangerous 60 light-year radius of Earth, the rate works out to about 2 to 2.5 supernovae per billion years. This estimate aligns remarkably well with the number of unexplained mass extinction events on Earth, specifically the Devonian and Ordovician extinctions, both of which occurred within the last billion years. While the researchers are careful to note that they don't have definitive proof these extinctions were caused by supernovae, the matching rates make it a compelling possibility. As Alexis Quintana, who led the study, put it, these findings are a great illustration for how massive stars can act as both creators and destructors of life. Supernova explosions distribute heavy chemical elements throughout space, essential building blocks for new stars and planets. But if a planet like Earth happens to be too close when these cosmic bombs detonate, the consequences can be devastating. So the next time you gaze up at the night sky, remember that those twinkling stars might hold both the secrets to life's beginnings and potentially the power to dramatically alter its course here on Earth. Next, let's take a look at a subject we don't visit too often, but this ID truly fascinating. In what could be a revolutionary breakthrough for astronomy, engineers and astronomers at the University of Utah have designed an innovative new type of telescope lens that might forever change how we observe the cosmos. Unlike traditional bulky lenses and mirrors, this new technology is remarkably thin, a flat lens with microscopic etchings that refract light in precisely controlled ways. The most striking feature of this lens is its incredible thinness. Measuring less than a millimeter thick, it's practically a wafer compared to conventional telescope optics. Yet despite its slim profile, the lens performs remarkably well in initial tests, suggesting it could eventually replace the heavier, bulkier components typically used in astronomical telescopes. Our computational techniques suggested we could design multi-level diffractive flat lenses with large apertures that could focus light across the visible spectrum, explained Rajesh Menon, a professor of engineering at Utah who worked on the project. The technology behind this breakthrough is fascinating. The team used a technique called grayscale optical lithography, a variation of methods typically used for etching electronics onto silicon wafers, to create microscopic concentric rings on a glass substrate. Most of the half-millimeter thickness is actually just the glass itself, while the ringed grooves that do all the optical work are incredibly shallow at just 2.4 microns deep. While the concept of using concentric rings in flat lenses isn't entirely new, this multi-level diffractive lens, or MDL, solves one of the biggest challenges in optics: chromatic aberration. This problem occurs when different wavelengths of light focus at different points, causing color fringing around objects. The Utah team's design cleverly brings all wavelengths, from 400 to 800 nanometers, covering the entire visible spectrum and into near-infrared to focus at exactly the same point. The weight difference is dramatic. Their 100 mm prototype lens, with a focal length of 200 mm, weighs just 25 grams compared to the 211 grams of a similarly sized commercial lens that's 17 mm thick at its center. That's more than an 88% reduction in weight. To demonstrate its capabilities, the team tested the lens by imaging both the sun and the moon, successfully revealing sunspots and accurate geological features on the lunar surface. This real-world performance validation suggests the technology is viable for practical astronomical applications. The implications for space telescopes could be particularly transformative. Consider that the Hubble Space Telescope's 2.4-meter primary mirror weighs a whopping 1,825 pounds, while the James Webb Space Telescope's segmented 21-foot mirror weighs 1,555 pounds. The tremendous mass of these components significantly drives up launch costs and engineering complexity. On Earth, the largest individual telescope mirrors currently max out at around 26 to 33 feet before gravity causes them to sag under their own weight. A flat, lightweight alternative could potentially break through these limitations, enabling even larger light-gathering surfaces, both in space and on the ground. Our demonstration is a stepping stone towards creating very large aperture, lightweight flat lenses with the capability of capturing full-color images for use in air and space-based telescopes, said Apradim Majumder, who led the team behind the prototype. While the current prototype is modest at 4 inches in diameter, the breakthrough proves the concept is viable. If successfully scaled up, these lenses could potentially transform not just professional observatories, but eventually make their way into amateur telescopes as well, making advanced astronomical imaging more accessible to everyone. In a stellar discovery that's illuminating our understanding of cosmic explosions, astronomers have conducted the first ever near-infrared study of a recurrent nova beyond our Milky Way galaxy. This extraordinary nova, designated LMCN 196812A or LMC68, resides in the Large Magellanic Cloud and has been revealing some truly shocking characteristics. Nova explosions occur in binary star systems, where a white dwarf, a dense stellar remnant about the size of Earth but with a mass comparable to our Sun, pulls material from its companion star. This stolen material accumulates on the white dwarf's surface until it triggers a thermonuclear explosion. While most novas have been observed erupting just once, LMC68 belongs to the rare category of recurrent novas, with explosions occurring with remarkable regularity every 4 years. A hot white dwarf star siphons off material from its cool companion star, explained astronomer Nye Evans of Keele University. The material piles up on the white dwarf's surface and eventually detonates in a thermonuclear runaway. Once the explosion has subsided, the siphoning starts all over, and in time, another thermonuclear explosion occurs. What makes LMC68 particularly special is that it was the first recurrent nova ever observed outside our galaxy. First spotted in 1968 and again in 1990, it has maintained its 4-year eruption cycle with clockwork precision. After its 2020 eruption, NASA's Neil Gehrels Swift Observatory had been closely monitoring it, anticipating the next explosion, which arrived on schedule in August 2024. The latest observations have revealed something truly extraordinary. During its eruption phase, This nova shines at nearly 100 times the brightness of our sun, making it an exceptionally powerful cosmic event. By analyzing the nova's near-infrared light, astronomers gained unprecedented insights into its ultra-hot phase. Using spectroscopy to examine the different wavelengths of light, they identified chemical elements present in the explosion and discovered unexpectedly intense signals from silicon atoms that had been ionized 9 times, a process requiring enormous energy. The ionized silicon, shining at almost 100 times brighter than the sun, is unprecedented, noted Tom Gabal, NOAR Lab emeritus astronomer. And while this signal is shocking, it's also shocking what's not there. We would have expected to also see signatures of highly energized sulfur, phosphorus, calcium, and aluminum. This absence of expected chemical signatures points to something unusual happening with LMC-68. The astronomers believe the answer might lie in 2 factors: exceptionally high temperatures and the star's location in the metal-deficient environment of the Large Magellanic Cloud. The coronal temperature of LMC-68 reaches a blistering 5.4 million degrees Fahrenheit, that's 3 million degrees Celsius, far hotter than typical novas. At these extreme temperatures, atoms undergo collisional ionization, where fast-moving electrons strip atoms of more electrons than usual, pushing them into higher energy states. Additionally, since the nova's companion star likely has lower metallicity, fewer heavy elements, typical of the Large Magellanic Cloud, this could lead to more powerful explosions, as more material is needed to trigger the eruption. What makes these recurrent novas particularly intriguing is their potential connection to supernovas. As Evans explains, in systems like LMC-68, less mass is ejected in the nova explosion than is gained by transferring from the cool star. This means that the mass of the white dwarf is steadily increasing. In time, it will approach a critical value above which the white dwarf cannot support its own weight, and it will implode, potentially triggering a supernova explosion. By expanding their observations beyond our galaxy and using the largest telescopes available, astronomers hope to increase their understanding of these fascinating cosmic explosions and how their behavior varies in different chemical environments throughout the universe. This weekend, Venus will reach what astronomers call an inferior conjunction, the moment when it passes directly between Earth and the Sun. This alignment happens approximately every 19 months as a result of the orbital dance between Venus and our planet around the Sun. The precise moment of conjunction is expected around 9 p.m. Eastern Daylight Time on Saturday. Despite being one of the most significant regular alignments in our solar system, this celestial event won't be much of a visual spectacle for casual observers. The glare from the sun makes it really, really difficult to see, explains Michelle Nichols from Chicago's Adler Planetarium. Those hoping to catch a glimpse would need specialized equipment and considerable expertise to spot Venus against the overwhelming brightness of the sun. Some astronomers have given this phenomenon a rather poetic nickname. Some people call that a Venus kiss because we're extremely close together, says astronomer Geary Albright from James Madison University, describing the momentary alignment of our 2 planets. Like our moon, Venus goes through phases as it orbits the sun. Just before and after conjunction, Venus appears as an extremely thin crescent when viewed through telescopes. For those interested in tracking this transition, the most noticeable change will be Venus's shift from the evening to the morning sky. In the days leading up to conjunction, Venus has been visible as one of the brightest objects in the evening sky, appearing near the western horizon shortly after sunset. After conjunction, early risers will have the opportunity to spot it in the eastern sky just before sunrise. However, observers should take extreme caution never to stare directly at the sun when looking for Venus. While this weekend's alignment might not provide dramatic visuals for most of us, scientists value these predictable cosmic events as opportunities to track the movements of planets and refine our understanding of celestial mechanics. Get a chance to get to know Venus, encourages Nichols, suggesting that even seemingly routine astronomical events offer valuable learning opportunities. The inferior conjunction has cultural significance beyond pure astronomy. Paul McCartney's song, The Kiss of Venus, was partly inspired by a book chapter describing this very phenomenon, showing how celestial events continue to influence art and music. Looking ahead, Venus will remain a focus of scientific interest. NASA has 2 upcoming missions planned to investigate our planetary neighbor in greater detail. These missions aim to reveal more about how Venus formed and why it evolved so differently from Earth, despite their similar sizes and positions in the solar system. As Venus transitions from being an evening star to a morning star after conjunction, it provides a reminder of the constant clockwork motion of our solar system, a celestial timepiece that has fascinated humanity throughout history. And to finish things today, a warning. As our energy needs grow alongside our technological capabilities, scientists are starting to consider what truly advanced civilizations might require for power generation. A fascinating new study published in Science Direct explores one of the most ambitious concepts in theoretical astroengineering, the Dyson swarm, and its potential environmental consequences for planets like Earth. Originally proposed by physicist Freeman Dyson in 1960, a Dyson swarm would consist of countless satellites or habitats orbiting a star to capture and utilize its energy output. Unlike the solid shell often depicted in science fiction, a swarm represents a more practical approach, allowing for incremental construction as a civilization's energy demands increase. The research, conducted by Ian Marius Peters from the Helmholtz Institute Erlangen-Nuremberg for Renewable Energy, examines whether such a megastructure could be built using materials available in our solar system while preserving Earth's habitability. The findings are both remarkable and concerning. According to Peters' calculations, a complete Dyson swarm surrounding our sun would dramatically alter Earth's climate. If positioned outside Earth's orbit, such a structure would raise our planet's temperature by a staggering 140 degrees Kelvin, rendering Earth completely uninhabitable. Smaller structures positioned inside Earth's orbit prove equally problematic, either becoming too hot for their own efficiency or blocking too much solar energy from reaching our planet. The study does propose a potential compromise: a partial structure positioned at about 2.13 astronomical units from the sun. This configuration could harvest approximately 4% of the sun's total energy output, an astonishing 15.6 yottawatts of power, while increasing Earth's temperature by less than 3 degrees Kelvin. However, even this more modest design would represent an engineering challenge of unprecedented scale, requiring approximately 1.3 x 1023 kilograms of silicon, an amount that stretches the limits of what might be available in our solar system. If constructed, such a megastructure would elevate humanity to a Type II civilization on the Kardashev scale, a classification system that measures technological advancement based on energy consumption. Currently, we haven't even achieved Type I status, which would require harnessing all available energy reaching Earth from the sun. While purely theoretical at this stage, the concept of Dyson swarms highlights the delicate balance between technological advancement and environmental preservation. As we look toward a future of increasing energy demands, particularly if we hope to venture beyond our solar system, these calculations provide a sobering reminder that even the most ambitious engineering projects must consider their impact on the very worlds they aim to benefit. Well, that brings us to the end of another fascinating journey through our cosmic neighborhood. From distant galaxies with unexpected oxygen levels to nova explosions outshining our sun, and from revolutionary telescope technology to the potential environmental impacts of theoretical megastructures, the universe continues to surprise and inspire us with its endless wonders. As we've seen today, astronomy isn't just about distant stars and galaxies. It directly connects to life here on Earth. Whether through ancient supernovae, potentially triggering mass extinctions, or the engineering challenges that might shape our species' future, the cosmos and our home planet are intimately linked in ways we're only beginning to understand. I hope you've enjoyed this episode of Astronomy Daily. I'm Anna, and it's been my pleasure to share these astronomical discoveries with you today. If you're hungry for more space and astronomy content, I invite you to visit our website at astronomydaily.io, where you can sign up for our free daily newsletter to have the latest cosmic news delivered straight to your inbox. While you're there, browse our constantly updating newsfeed to catch up on all the latest developments we couldn't fit into today's episode, and explore our archive of past episodes. For those who prefer their astronomy on social media, you can find us by searching for Astro Daily Pod on Facebook, X, YouTube Music, Instagram, and TikTok. We regularly post fascinating space imagery, breaking news updates, and bite-sized astronomy facts across all our platforms. Thank you for listening to Astronomy Daily. Until next time, keep looking up, The universe is an amazing place, and we're just beginning to understand its secrets.